Hi guys, I'm going to take you through functional graphs. And functional graphs, it simply means it's a graph of functions. So with these graphs, I'll show you how you draw them and a bit of explanation on how you sketch those graphs. We'll go through linear graphs, which is given by a function f of x equals to x, or alternatively, y equals to x. I'll do with you inverse functions, which have got a form f of x equals to 1 over x. Alternatively, is y equals to 1 over x. The quadratic function is a basic function, which is f of x equals to x squared. The cubic function with a general function, which is f of x equals to x cubed. Exponential functions, they have a form which is f of x equals to a to the power x, where a can be any number, a constant. The alternative form is y equals to a to the power x. We also have logarithmic functions with a general form of y equals to logarithm of x, or y equals to ln x. So all those functions are the functions that I'm going to take you through them just now. So to start, I'll just introduce to you the linear function. So this is the linear function, and we also know that linear comes from the word line. So in other words, linear functions are described by a straight line, and the straight line passes through certain points according to the equations. But in the basic equation of a straight line, I'm going to use f of x equals to x, or y equals to x. And this function, or this general function, means whenever x is 5, y is also 5. So when x is 5, y is also 5. When x is 2, y is also 2. So when x is 0 here, y is also 0. And when x is 1, for example, y is also 1. When x is 5, y is also 5, and so forth and so forth. So this is a linear function. So when you're plotting, or when you're sketching a function of y equals to x, this is your x-axis, your y-axis, and then your graph is just a straight line with the same coordinate for x and for y. That is your graph. So whatever value of x here, you also get the value of y on the y-axis. Now let's look at the inverse function with a form of f of x equals to 1 over x. This inverse function is written as y equals to 1 over x when x is not equal to 0. I should explain that in a minute. What it means is that you cannot have x values becoming 0. How do I mean? Remember, if x is 0, the function becomes y equals to 1 over 0, and 1 over 0 is undefined. Or it's going to give you an infinite value. So where will you plot that value on the y-axis? That will be a challenge. So what we do is, there is no way we plot on the y-axis when x is equals to 0. There is no value for y when x equals to 0. But when x is very small, but not 0, we are going to get a very, very big number. So close to 0, there are high values of y, when x is very small. Let me just demonstrate. Let's start with 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, and so on and so on. So this is x, this is f of x. If you have this is 1000. These are the answers that you get when you find f of x. And as you can see, when x is very small, y is big. But when x decreases, when x increases, y is decreasing. So suggests that this graph is like this. When x is small, y is big. But when x is big, y is small. The same thing applies on the negative side. That's what you get. But what you have to take note of is that you will never get values on the x-axis and on the y-axis. And these are called asymptotes. Asymptote. This one is called the horizontal asymptote. This y-axis is called the vertical asymptote. What is an asymptote again? An asymptote is a line where the values either of x or of y do not exist. So there are no values that are plotted on the asymptote. So an asymptote is generally a line of restriction which restricts the presence of values, for example, of x or of y in that region. So we're going to move to other graphs. The next graph that we're going to look at is a cubic graph. So a cubic graph is represented by y equals to x cubed. And we know that when x is 0, y is also 0. Let me use this one. Y is 0 when x is 0 from this equation. But when y is increasing, so when x is increasing, y will also increase by a very big number. And when x is decreasing, y will also decrease by a bigger factor. So the graph will look like this. Take note. X cubed. If x is 0, this is 0. If x is 1, 1. If x is 2, 8. X is 3. This is 27. 4. So the values of x are increasing steadily, but the values of x cubed, they are increasing very fast. So that is why this graph is not straight, but keeps on increasing like this one. And on the negative side, the same applies. That is a cubic graph for y equals to x cubed. Right, I'll then move on to y equals to x squared. So the graph of y equals to x squared is a quadratic graph. All these graphs that I'm presenting to you, they are basic graphs. They are transformations that we said we'll talk about in a different session. This one, you can quickly look at this. if this is your x, this is your x squared. If x is 0, y is equals to 0, x equals to 1, y equals to 1. X equals to 2, x squared is equals to 4, 3, 9, 4, 16, 5, 25, etc. So the right side of this graph is going to increase with increasing gradient like this. What about the negative side? If x is 0, 0, if x is minus 1, you still get a 1. Minus 2, you still get 4. Minus 3, you still get 9. Minus 4, 16. Minus 5, you still get a positive 25. So the graph is still above the x-axis, but on the negative side of x. So this is how it goes. Not going to sketch something that is perfect, but you get the sense. This is how it's going to happen. This is the graph, basically. Now let us look at the exponential and finally the logarithmic graph. It is important to note that the logarithmic graph is a function y is equals to a to the power x. Like I said, a is a number. A is a number, any number. Okay? So I'm giving you an example like y equals to 3 to the power x. As usual, this is the y-axis and this is the x-axis. So how are we going to plot? Take note that y can never be 0 because there is no way where you can say 0 equals to any number to the power x. Which number can that be? It can't work. So y is never 0, therefore the x-axis or the line y equals to 0 is an asymptote. This is also the x-axis, so the x-axis is an asymptote. Okay? So the graph will never touch this line. That is very important to take note of. Now, what happens if values of x are negative? So you've got x 3 to the power x, but x is negative. So x is negative 1, x is negative 2, x is negative 10, negative 100. These values are going to rapidly decrease. So I'm bringing in a calculator to show how this is going to happen. So when x is minus 1, this is sort of going to be 0,3. When x is negative 1, 0,3 is your 3 to the power x. What about x is negative 2, 3 to the power negative 2. I'm getting 0,1. 3 to the power negative 10. I'm getting an even very, very small number. So if I get to 3 to the power negative 100, it's just close to 0. It's very, 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 very small. Right. What if x is 0? If x is 0, then I'll get a 1. Let me show you. 3 to the power 0 is 1. So at this point, I will have a 1 there because x is 0. So I'll have 1. But below the values are dropping. What happens if the values are positive? Let me use 1, 2, 10, 100. This is x, this is 3 to the power x. If x is 1, I'll get a 3. If x is 2, I'm getting a 9. If x is 3, I'll get a 27. If x is 10, 3 to the power 10, I'm getting 59,049. And this is even greater. So, for each stepwise increase in x, there is no stepwise increase in y. The increase is very large. So, when you're plotting this graph, on the right hand side, take note the graph just shoots up like that. But on the left hand side, the graph drops. Is closer to 0, but never touches the x-axis. So this is your graph of y equals to a to the power x. In this case, we're going to use 3 to the power x. That's how it is. There it is. Right, to finalize this, I'm going to do the logarithmic graph. For this graph, I'll ask myself, what is logarithm of 0? So let me just say ln 0. Oh, it's error 2. There is no value. So what does it mean? It means that this line is an asymptote because x cannot be 0. Let me state it. X is never 0. It's important to take note of that, so that you put your asymptote in place. Right, what about if x is 1? So your ln 1 logarithmic of 1 is 0. So it's going to be there. So when x is 1, y is 0. What about other values? If x, say, is half, so you've got ln 0.5, you get negative values. Okay? So it tells you that the graph is going to go down like this, because we said there are no values on the x-axis, so the values will drop, but close to the y-axis we will get values for x is too small and y is very small or is very negative. Right, above the y-axis or above the x-axis, what will happen? Let's see. What about ln 2? 0.69. Ln 3? 1.09. Ln 4? 1.38. They are increasing, but not by very much. So this is how this is going to play out. Something like this is your graph. All right, this graph is increasing, so make no mistake about it. Next time we meet, we're going to look at the transformation of these graphs. We're going to pick some of the graphs and demonstrate the transformations. But for now, let's call it a day. Bye-bye.